All right, what is up, my little pre-calc students? Let's talk about how to do polar form of a conic. Woo, I already was practicing. All right, let's clear my calculator. Second plus 7, 1, 2. That's gonna be a great video. All right, so you're gonna go to your mode, just like we were doing with that graphing activity. And then I want you to go to polar. Okay. I'm going to go ahead and put it in degrees because it's just easier to work with. Like you can do this in radians, but then you have to go from like 0 to 2 pi, and then you got to do every pi over 12. Like that's just doing too much. All right, then we go to our window. And remember, so theta min, that's going to be 0. The whole unit circle is 360 degrees. My theta step, what we had was, remember we didn't want it to be too small, but we didn't want it to be too big. So I'm going to make this 5, every 5 degrees or every 15. I can't remember what we did. 5 or 15. I'm going to do 5 and it will be okay. All right. So 5, 15. Don't do something like 30 or 60. Like then it's just going to graph too fast. All right. We are going to go to y equals. Now I'm going to graph problem number 1 in your examples from your notes. So, we're going to graph that guy, the r equals 6 divided by 1 minus 2 cosine theta. So let's go to, if you have the newer calculator, you want to do alpha y equals. Okay. And I'm going to type in 6 over 1 minus 2 cosine theta. And close my parentheses. All right. So that's how you type it in. If you have the older calculator, you have to do 6 divided by everything in parentheses on the bottom. Parentheses 1 minus 2 cosine theta. Close your parentheses. All right. Now we can hit graph. And we have a beautiful looking hyperbola. And so then see how it graphed it. It's able to make this a nice smooth curve. So if I was calculator active, and you just didn't remember anything, but again, I could have probably asked this calculator inactive. This is why we would have 2 versions of the test, because you want to know. So here, my E value was 2, my P is 3, but it was the directrix. So the directrix of a hyperbola is in between right here. 1, 2, oh, no, it's right here. Sorry, I just lied. That's my center. I don't know what I was thinking. There's my directrix. And so it created my parabola or hyperbola. It's 3 units from the pole. You can't see the directrix. Of course, it's never going to graph it. So let's just do one more, and I'm going to type in that second example. So the second example was, and I'm going to type it in the other way. Whoop, that is not a 3. 3 divided by, redo. I'm trying to type this in without looking at my calculator. 3 divided by parentheses 4 plus 2 sine theta, and then close my parentheses, and I'm going to close it again. And then based on this problem, it should create an ellipse. And that's a very small ellipse. If you hit zoom square, that will make it more look like an ellipse. So you can even zoom in. Let's do zoom 2. I'm going to do it one more time. Zoom 2. Oh, I hit zoom 4. Whoop. Zoom 2. And then hit enter. And then zoom 5. We'll start making it look like an ellipse. And half of my ellipse is gone. You didn't have to do all that zoom in. So you can zoom out again, zoom 3, hit enter. Now we're getting closer, and I'm just going to square it up. That just makes it a little bit more perfect instead of looking like a circle. Sometimes if you type this in, if you don't hit zoom square, that ellipse is going to look like a circle. And this is definitely not a circle based on what is going on. Like we would be equidistant from both sides. So this is definitely going from the center here is way more than 1. And then from the center here is a little bit less than 1. And then so this one we had y equals 3 halves was my directrix. So remember the pole is one of my focus points. So the directrix is above it, and this is what I was talking about. This is the position of the ellipse. It would be below my directrix, okay? Because that's where the pole is, okay? So if my directrix is above the pole, the picture is going to be below the directrix. All right, thank you for watching the second video. Bye.